What's up, guys? Welcome back to another mislike video. We're back at it with the zeros and negative exponents. Let's go, ka-chow! Back at it.
I'm so proud of you. So you're not proud.
I did.
I'm so proud of the goal.
I mean, just
she's so proud of me.
So, just like Lex said, we're doing zero exponents and negative exponents. We just went over, off camera, we went over that anything to the zero power is going to be 1. Even expressions that are like super crazy, like what if you see something that's like 36 x to the 6th, y to the 3rd, z to the negative 8th over 4 to the, 4x to the 2nd, y, and then z to the negative 5th, and then that whole thing is to the 0 power. What's the answer? 1. Very good.
Wait, why? Oh, because sorry.
The 0 exponent 1. Anything to the 0 powers. That's the super easy one. This rule people are having a harder time with. The concept is really simple and quick, but for some reason we're having a hard time with it, like my other classes are. So just really focus in on this. Negative exponents have a negative attitude.
I have a here with
basement.
Go. How do you know?
What?
I know, like, learned that.
Oh, okay. Good.
What?
Oh, did we talk about it on Friday?
I don't know where I got it. I just
What?
know that that's what we do.
Okay. Yeah.
Jill told me.
What is going on right now?
Have you ever been to St. Augustine where you see like the oldest schoolhouse?
Yes.
And they have the dungeon?
It was boring.
Oh yeah, I was playing that when I was a kid.
If the student was being bad, had a negative attitude, the teacher would say, "Go down to the dungeon."
My dad says that for
We
me.
have a day spring dungeon. I won't mention any names.
We added a day spring dungeon.
So if the exponent is having a negative attitude, it's got to go down to the dungeon, okay? Or the basement, or downstairs, or whatever. The And what's that exponent going to do? It's going to get a more positive attitude. So when that exponent with its base moves down to the dungeon, it's got to get a positive attitude, okay? It's going to learn its lesson. So 7 to the negative 3rd power simply becomes 1 over 7 to the positive 3rd power. All it's doing is switching from the numerator to the denominator. Yeah.
Why doesn't the 5 make a positive in that one?
Because it's only, this rule is only for negative exponents, not negative bases, okay?
So say it was like -5, but even if it wasn't in parentheses, would it still be -5?
It's a really good question. I'm actually gonna go over the difference between this with parentheses and this without parentheses in just a second. So does everybody understand? Stop wrong with you guys. Does everybody understand this part? Where it's in the numerator, even though it doesn't look like a fraction, anything that doesn't look like a fraction is simply a fraction that's a numerator that's over 1, right? So this moves to the denominator, and then if the denominator is empty, if the numerator is empty, of course there's going to be a 1 there, right? Okay. Now over here, I'll go through like the basics of this, and then I'll go through like the 2 different ways to look at this with the parentheses. Okay, so what is the base of this negative exponent? What is the base of it?
2, 5, negative 5.
Negative 5 is the base.
Is that
Okay.
just the answer of that example?
This is the answer, but if you were to simplify it more, you could do 7 times 7 times 7. I'd have to get a calculator to tell you. By the way, do you know there's a function on your calculator? Instead of doing 7 times 7 times 7, there's a function that says y to the x power.
Yeah.
It's right underneath the off button. So let's say you want to do 7 to the 3rd power. Go to the home screen, like clear it.
Whoa.
Type 7 as your base.
343.
Then just go to the y to the x power button, click it once, and then type in your exponent, and then you'll get it. So this would be
10.
1 over 343, which is the final answer.
Wait, so 3, so 7, 7, 7, 7, 7.
I'm sorry, I'm trying to see, is that an N next to the A?
Yeah.
Okay.
Is that better?
Thank you.
All right, let's take a look at this now. So the base is -5, and it's in parentheses for a reason, okay? If we were, so if it's to the -2 power, it needs to get sent to the dungeon or the basement or the denominator, whatever you want to call it. And that will give it a more positive attitude. It's only the negative exponent that changes. Now, if we were to continue to simplify this,
I know why it's in parentheses. If it's multiplied by like a negative and if the exponent is even, then it'll like be a square. Never mind.
you're kind of on the right track, but I'll explain it in a second. Okay. Girls. So when I simplify this, what am I squaring here? What am I squaring?
2.
The -5. So the -5 is being multiplied times itself, which will give me what?
Negative, or 10, 25.
Positive 25, right? -5 times -5 is positive 25, right? Okay. What if this said 1 over -5 squared? When I said it out loud, it sounded like the exact same thing. This is 1 over -5 squared. This is 1 over -5 squared. Sounds like the exact same thing.
It does.
I know.
I wonder why.
What? Did I explain this in intensive math? Is that what? Oh, okay, go ahead, you explain it.
So it's like it'd be negative 25
Mhm.
because if you just multiply -5 and 5.
No, that's not why.
You didn't explain it fully. But you didn't. You just said it's
Why?
either -25 or with the parentheses. Sorry, positive 25 in parentheses, and then negative 25
Equals
out the
1 over
parentheses.
negative.
When there isn't any parentheses, you're not multiplying the negative sign with it. You're just multiplying the number.
Right. So what we're actually seeing here is a battle of order of operations. They're kind of fighting over which one goes first. Now you're like, what operations? Is there only exponent? No. Can you sit there? There is the operation exponent, and there's also the operation of multiplication. So this is 5 squared times a negative. That's the order of operations. 5 squared, which is 25, times a negative. The negative is actually being multiplied, and that comes after the exponent. So if it doesn't have parentheses, then it would be negative 1 over negative 25. If it is written without parentheses, that means the base of this exponent is only the 5, and the negative is being multiplied by that. number. Do you understand? So that's why the negative kind of gets tagged on at the end. All right, let's go to some examples.
Are you supposed to remember when if we get it right, are you just counting?
I don't think today. All right, what is the simplified form of each expression? So we have 9 to the negative second power. It's got a negative attitude. Where does it belong?
The torture
The
chamber.
dungeon, known as the denominator. So the 9 to the negative 2, to get a more positive attitude, will have to go into the denominator, which will leave the numerator as simply 1. And then, of course, 9 times 9 is 81, so you would get 1. Yeah, you do.
On the homework.
But that's what-
simplify.
Yeah, that's, but it doesn't, it's like, there are only a couple of ones that you'll actually have to do that, and you have a calculator, so no big deal. So that would be 1 over 81. All right, how are we doing on time? All right, let's look at B, hardest question ever.
What?
Negative 3.6 to the 0 power is 1. What if there were what if there were no parentheses there? What would the answer be?
1.
It would be negative 1. Very good. If there were no parentheses, and it was 3.6 to the 0, negative 3.6 to the 0 power with no parentheses, that would be 3.6 to the 0 power is 1 times the negative is negative 1. But that wasn't. All right, you guys are going to do the got it problems. They're called got it problems.
got it.
Yeah.
Instead of the try it problems. Silently, you are going to try A, B, C, D, and E. While you are doing that, I'm going to come around and ask to see your corrections. Did you already show me your corrections? Nice. Oh yeah, and I was watching you. You did that. Okay. That's good.
This,
Wow.
this, this.
That's really good. Did you do your corrections? Is that your corrections? Well, you didn't finish yours, right? Yeah. So you don't finish yours. You didn't finish yours?
I did.
Did you finish yours?
What?
Did you finish yours?
What?
Well, did you finish? No. Then show the screen. And you didn't finish, right? Natalie, did you finish yours? Oh, you showed me yours. Yeah, okay. And, Melanie, you're gonna show me tomorrow?
Miss Lee,
Yeah.
if it's a negative but it's to the 0 power, does it still equal 1?
As long as it's inside the parentheses, then that means everything's to the 0 power, which means it will equal 1. What? What happens when there's a negative exponent? It's sent to the dungeon. Once it goes to the dungeon, it gets a positive attitude.
Never mind. I was confused with the exponent. That's like what I was because it's the 1.
Which one?
Hey. Okay, now?
Yeah.
Now?
Yeah, right now.
It'll be 1 over 6 or 6 negative.
Now?
What are we saying?
Hey, Miss Lee, If it's a negative but it's not in parentheses, will it
Let's just
equal
put it
but
right
it's
here.
0 power?
Where do you
Where
want
do
me
you
to put
want
it?
negative?
Right here. Right here?
Oh wait, are you talking, which one are you talking about?
No, like I'm just asking.
Yeah.
for-
Okay, go ahead. Yeah, you can do A.
That means you're adding to negative 4
That's
Great, and then all you would do is pop that into your calculator. Thank you. Good job. So Grayson did A, but we're gonna continue to simplify that, so we'll just put
It's 64.
4, the third power, 64.
64.
So that would be 1 over 64 for A. What about B?
It's 1.
It's,
1. And Bo, what'd you get for C?
See, I got 9.
What?
9.
Or
1
no,
over 9.
1, yeah, 1 over.
Yeah, because you had 1 over 3 squared, that's
Yeah.
good. But then you just totally abandoned all rules for fractions.
I know.
1 over 3 squared equals 1 over 9.
Oh wait, I actually might be good at this.
Yay!
yeah, I actually.
All right, so what's D? Faith? 1 over 6, very good. 1 over 6 to the 1 power, but really it's 1 over 6. And then what about this crazy thing?
1 over 16.
1 over 6.
Yeah, 1 over 16. Because the first step would be 1 over negative 4 in parentheses to the positive 2 power. And then that would give you 1 over 16.
Who did that?
All right, don't let this freak you out. It's the same thing that we just worked with. We just have a few more. We have a few more things involved, but nothing's changed. We have 5 times an a cubed times a b to the negative 2 power. In terms of numerator denominator, since it doesn't have a fraction in denominator, can we consider this to be in the numerator? Okay, right? We can consider that in the numerator, right? 5a cubed b the negative second. Before I change anything, I'm just gonna say, well, technically that's in the numerator, right? And that will help me organize what's gonna stay in the numerator and what's gonna have to move to the denominator. Tell me what can stay. No, tell me what can, tell me what can stay in the numerator. Okay, 5, good. Anything else that can stay? Yeah, the a cubed. What's gotta go? It's got a negative attitude. It needs to be sent to the dungeon to get a more positive attitude. Are we done?
No.
You guys always think I'm. You guys always think.
Because
I
of
know.
your smirk.
And so I'm like, are we done?
No.
No, ma'am. No, we gotta keep going.
No.
It's gotta be. No, we're done. Okay.
So, Miss Lang, what if the exponent of the bottom is a 0?
What if this is a 0? Then it would just cancel out. So just like if you had, like, if you came out with the answer of 5 over 1, you would just simplify it to 5. So anytime you have a numerator denominator where the denominator is just 1, just put the numerator, just write the numerator as a whole number. All right, let's do B. Okay, so here's a situation where the negative attitude is already in the dungeon. So Who lives in a 2-story home?
I used to.
I do.
Is your bedroom upstairs?
Yes.
Good. If you are hanging out downstairs
Okay.
and you get a little sassy, little negative attitude, you can just not be in there.
I like my room.
Me?
Does your mom? Yeah, not that that would ever happen to you.
But sure. Yeah.
Okay.
Yeah.
Does your mom or dad ever say, go to your room?
No.
Yes, when I was little.
Never.
Mom does.
For real, they've never said that to me. They've never said that to me.
When I was
Ever.
Thank you. Okay. Story about little Grayson is over. Little Jossie, okay? When she's got negative attitude at home, on occasion, what do your parents do? Go to your room, because what do they want? You to fix your attitude.
I like my room.
That's wonderful. And it makes you, when she goes to her room, it gives her a more positive outlook on life. So here's little Jossie, okay? With her -5 attitude. So she's got to go upstairs to her room and think about how to be more
More
positive.
like one.
I thought she went downstairs.
She is downstairs in her house, and her parents are just sick of it.
Yeah,
Such a negative attitude. So they say, go upstairs. I can't
I do with you right now.
I can't be the only parent who does it. Go, just go. Go upstairs. I can't with you right now. What?
You do that weird.
Oh yeah. Just go.
My mom
Go upstairs.
did it. My mom
Go to your room, close the door. Yeah.
did
Just go away. Yeah. And usually it fixes their attitude because then they come back downstairs and they're like, I'm better now. Like, oh, so sending you upstairs gives you more positive attitude.
No, it's not that.
So guys, look. That's it. So if the negative attitude is down here, just send it up to get a more positive attitude. And if that causes it to be over 1, then it's just a
What
whole
happens to
number.
the positive thing on top? Does it just always go to the bottom?
So this didn't move to the bottom. This
You know
is
what I'm talking about? Like, I'm looking at the homework. There's one like that, except it's there's an 8 on top. So would that go to the bottom? Or
no,
would they all-
anything that has a good attitude stays exactly where it is.
Okay.
It's only negative attitudes that need to change, and only the exponent and base of that exponent that need to go with it. Okay? All right, let's try these got it problems. See if you can get them all right.
If you get them right, you can
Sure. If you get every single one of these correct on your first try, you get a good
Oh, she hit it.
It's down low. Anybody bring me more candy?
I got you. I gave me like a buttload of candy.
Are we trying to do all?
Just like, either like Jolly Ranchers or like little bite-sized things like this are really good.
What if I bring like a pound of Skittles?
Yeah.
Wait, how do you?
Dumplings.
Those are good. I have a question.
Oh, okay.
They all taste the same.
I have a question.
They're all the same flavor. It's just
Wait, would this be the answer?
It's really not a good
I'm gonna do it.
Who's calling you?
Do you have another piece too?
Can I have
Can I have it? Okay, good.
Go. Quiet coyote. I will let it go.
Yeah, well, the exponent would
Stay here with you.
Please make your answers very neat if you want me to come check them for candy. Huh? Yeah, you ready? I'm just writing down the answer.
He's easy. He's easy.
then then after that, it's upstairs, and after
Because why do you move to the denominator? Isn't there anything wrong? And this. Yeah, this is wrong also. Okay, we're gonna have to just go over.
Is D already answered?
no, I don't know.
How do you
It's the
guess?
same thing.
Oh, so close. That
Can
was
it
wrong.
stay on the bottom?
Oh, it would be.
What if it's a number here, then it's
I literally had it. I had it.
I only move it if it's part of the negative exponent. If it's the base of the negative exponent.
Put it back. Nasty.
I got it. Next time I didn't check my work. I'd be wrong.
Did you say snacks? You took another bite.
D and E are wrong.
I don't even want to do anything because I'm not gonna get half of it.
A is wrong. Some of it.
Then we gotta get it right this time. Did I get it right?
Why did it go silent?
Oh, shut.
Just like I got him right.
Time's up, we're going over them now, okay? What's this one? What is this?
Oh,
1 over x
1
Good.
over x9.
1 over x to the 9. Good.
Wait, what?
What's B?
And no, wait. Oh, you didn't even put 1 over
and 3.
Just enter the 3.
12.
So this has got to move up to the numerator and to the third. And then the denominator is just 1, so I don't need a denominator anymore. So it's just n to the third. That's it. C. And now here's the thing. The only part that has to move with the negative exponent is the base that's with it. 4 is not part of the base of this exponent. 4 is being multiplied. That comes later. So the exponent gets taken care of first. This moves to the denominator and becomes positive. So it's out of the numerator. What's left? 4 and B are on top, and C to the third is in the denominator. Does that make sense now?
Mm-hmm.
Faith, I know you were questioning this one.
What?
You weren't paying attention, I just went over it. The C to the negative third power, that's the part that's involved with the negative exponent. Only the C connected to the third power. The 4 is not part of that base.
You said that minus
Big
5.
and good.
I get from upside down, but I ended up doing like that.
What?
You said that I switched, so.
Oh, okay, then I misunderstood what you did, because I thought you said that you just, I don't know, I misunderstood. I thought you fixed your mistake. Okay. Do you understand why this is the way it is now? Okay, do you understand this? That the 4 and the b are not attached to anything negative, any negative exponent, so they're allowed to stay in the numerator. It's the c to the I'll erase this. The c to the negative third, that has to go downstairs because that's the one with the negative attitude, so it can become positive. But what?
Don't you multiply the c by the 4 and then
So with order of operations, since exponents come first and this exponent is negative, it has to move. And then it can get multiplied times whatever it needs to be multiplied in the denominator, which there isn't anything. So this 4 isn't attached to the c. It's theoretically being multiplied by this, but since you have to simplify this first in terms of order of operations, PEMDAS, exponents come before multiplication. So when this gets simplified, it moves and it's no longer being multiplied by the 4. You understand what I mean? Over here, what do we have? Is the 2 doing anything wrong?
No.
No, so it stays in the numerator. What about the denominator? What's going here on here?
It's negative.
So where does it go?
The basement.
No, it already is in the basement.
Oh, it goes to the upstairs.
Yep, so
I'll get it up
2a cubed, and then what about this one? Charlotte, you do this one.
First you have to,
Bye, Natalie.
first
You're
you
leaving.
have to put,
Just wait until everybody's packing up, honey, just so we don't do a thing. What?
You have to put it,
Okay, I'll give you a fraction bar, there you go. Does this stay or go?
it goes.
Okay. So now it can be positive, right? Does this stay or go?
It goes. It
Goes
stays.
where?
Upstairs.
Shh. Sorry. What? Why is it moving?
Because, you replaced it.
But it's m to the positive 2. A positive exponent is good. It stays where it is. M squared, there's nothing negative about it. It doesn't have a negative attitude, so it doesn't have to leave. Do you understand what I mean? So if Jocelyn is having a good day and she has a positive attitude, her parents aren't going to be like, hey Jocelyn, what a great attitude. Go upstairs, I don't want to see you. They're all going to be like, okay, then that'd be very sad. If this has a positive attitude, just let it stick around. So it would be in the denominator where it was. Now what's in the numerator? 1. Now, the only thing that I'm going to change about this, and there's nothing wrong with the value here. I'm just gonna switch these because every time we write an algebraic expression with multiple variables, we want them in alphabetical order. It's just to keep things organized. There's nothing wrong with this. It's just that we want to write, because it goes L-M-N-O-P, L-M-N-O, right? So it would be 1 over m squared and to fifth. If you wrote this, I didn't count that as wrong, just you can go now. Right, you guys can go.